back. Now that we have a very deep understanding of applying simple operations to the function or the argument of the function, we can continue to graph more basic functions, but with a little bit of more complexity. We're going to get to that in a second. So the fifth that we're going to graph is called the inverse function. And it's nothing as complicated as you may have thought. It's just as simple as 1 over x, the inverse function. All right? We can normally do k over x, and k is a real number, but we're going to do 1 for the sake of the exercise. What we're going to do is draw our axis, xy, all right? And the first thing that you have to know is what happens when x equals 0, right? Well, as you may have seen in another past video or another of the future videos, I'll always insist on not being afraid of zeros and denominators of fractions, okay? I'm going to give you a little bit of a tip right here. Number A, 0 over something, and k, as you may have thought, is a real number. Can be anything: 0 over 8, 0 over pi, 0 over e, 0 over minus 10. 0 over something is always 0. B, k over 0, and then be plus or equal infinite. All right? Now, why is this happening? Is this some sort of deal that I have to accept only for blind faith? Well, you have to think about math as in normal, regular life. Imagine if you had a pie, okay? It's a simple pie. Too bad, eh? Let's say we have 2 people, A and B. We have John and we have Mary. 1 pie for John and Mary. The logical thing is that we would like to divide the pie into halves. 1 half for John, 1 half for Mary. So we split it into 2 parts. Okay, that is a normal division, and that is what we refer to as 1 half. Alright, each side of the pie is 1 half. And when we add both halves, we get the full pie. Okay? Now let's see what happens if we have another guy right here called Henry. Okay? Well, if we want to divide the pie equally, we can't do it in halves anymore. So we do it in thirds. It's going to look a little bit like a peace symbol, right? We have 1/3, 1/3, and 1/3. Maybe a little bit bigger than that. Looks like the other part was a little bit smaller. Okay? So we have 1/3 for Henry, 1/3 for John, 1/3 for Mary. In this case, it would be 1/3. Okay? Pretty simple enough. Now, let's think for a second, logically. What happens if we have no pie? There is 0 pie. Well, how many slices is each one of them going to get? If we have 0 pie to divide among 3 people, well, unfortunately, we're not going to get any. So 0 over 3 equals 0. Okay? And you can do this with further numbers. If we have 4, 5, 10 people, if we have 0 pi, they're all going to get 0. That's why 0 over k, and k is a real number, equals 0. Now, what happens if we have the opposite example? Say we have 1 pi, but no people. See? There's 1 bit pie, but no people. How many slices are for people? Well, since there's no people, the whole pie is infinite. It becomes infinite. There's too much for everyone. Why? Because there's no one. That is why k over 0 can equal plus or minus infinite. In general, we can do positive k equals positive k over 0 equals positive infinite, and minus k over 0 equals minus infinite. Okay? That is simple, and it's good enough to realize how we can apply math and think of math in simple, basic, normal life terms. How does that work with the inverse function? Well, simple. Okay? The plot of the inverse function is going to look a little bit like this. What happens if we have x equals 1? Well, 1 above 1 is 1. What happens if we have x equals minus 1? Well, 1 minus 1 is minus 1. What happens if we have x equals 2? Well, 1 over 2, 1 half. What happens if we have x equals minus 2? Well, then we have minus 1 half. What happens if we have 3? Well, 1/3. Minus 3, minus 1/3. You can see pretty much the pattern like I told you before. Realizing the pattern is the key to graph basic functions. Right? There's a pattern. The higher the number, if it's positive, the lower the y is going to be. Again, positive. The further away to the minus infinite the negative number is, the smaller the number is, the smaller infinite. Okay? So if this is 1, 1, minus 1, and minus 1, well, 1 and x equals 1 and y right here, while minus 1 and x equals minus 1 right here. So if this is 2, well, this equals 1 half over here. If this is 3, it's 1/3 over here, and so on. If this is minus 2, it's going to be minus 1 half right here. If this is minus 1/3, this is minus 3, it's going to be right here, and so on. Okay? It's going to be like something like this. This is the inverse function, all of it. More steep. Okay? The higher the number that goes to the right, or the more right the number is on x, the closer it's going to get to the x. The more closer to the minus infinite the number is to the left side, then the closer to get to the minus x side on that side. And if the number is small, then it goes up. And the y side, if the number is small, but to the negative side, it goes down. Right? But as you can see, if x equals 0, that means it's infinite. So let's say if we have x equals something very, very tiny, like minus 0.0000000000001, well, the number of the y chart is going to be all the way down here. If we have something positive, let's say 1 over x, and x equals 0.000000001, then the number goes all the way up. Okay? This is the plot of the inverse function. Now, as you may imagine, I may be able to do a little tweaking with it. Okay? What happens if we have, say, y equals 1 over x plus 1? Well, as you can see, all I did right here is add 1 to the function. So all that 1 does is moves the inverse chart one step up. All right? All it does is add 1 step up. So if this is 1 right here, we're going to think of 1 as an imaginary x-axis. And the plot of the function is going to be exactly the same, but 1 step up, like this, and like this. See? It's the exact same as the blue 1 over x, but 1 step up. Okay? Another example. What happens if we have, say for instance, 1 over x minus 3? Well, this is fx, and all that's happening right here is that it's being displaced minus 3 spaces down. Okay? So if we count minus 2, minus 3, and we think of minus 3 as an imaginary axis right here, the plot of the function is going to be exactly the same as 1 over x, only displaced 3 elements down. It's going to look something like this. And over here, there you go. It's exactly the same, only 3 elements displaced. All we're doing is doing operations to the function, adding or subtracting, positioning north or positioning south, the inverse function.